So in this video we're going to talk about containment. Here we have a fairly average type of suburban property. We're going to have a look at a couple of scenarios inside of potential mould problems and how we can contain those different areas using different methods. Let's go and have a look. So our first imaginary mould problem is going to be in bedroom 1, just inside the front door of the property. For the purpose of the video, we're going to say that the mould problem extends to nearly every wall, or at least an unknown amount of walls inside this room. So we want to go for full room containment to be able to isolate this area off and not disturb any mould spores that will end up throughout the house and contaminate the rest of the house. So how can we do that? Well, obviously we don't want to build a containment inside this room in this case, because we want to open up the entire room for us to be able to work in and remove all the wall linings. Obviously the first thing we'd do is remove all the contents out of this room, of course. But as far as containment goes, what do we have to consider? Well, we have a couple of windows here, or 3 windows, they're all opening windows, so we can allow fresh air in through any of those openings. We could also use any of those openings to put our negative pressure unit or our air scrubber in the hole and pushing that air out to maintain negative pressure. So another important consideration is whereabouts in the property the problematic room is. So here we have the room that comes off into the hallway just adjacent, or the entranceway adjacent to the main front door. So in talking to the customer, we can establish that they have another couple of doors that they can come and go from throughout the project. So we can in fact block off this whole front entrance and they can still use the house effectively and come and go as they please. Another consideration is, do we want an airlock? And if we do, how do we form the airlock? So an airlock is a secondary containment outside the main workplace, which is used as a clean down room and is able to maintain that negative pressure by having 2 separate openings. So in this case we have a door here and we have a door here that can be used as our 2 primary openings into our airlock and into the work site. So all we have to do here is build some containment wall across this area here, which means that then we have our work site with a door on it and we have our airlock with our secondary door on it. And then all we have to do is seal up these louvers so that they don't leak too much air. Here we have our second scenario in this building. We have a semi-open media room with no closing doors. How can we contain this area off? Well, we could establish with the client, do they use that first bedroom? If they don't use that first bedroom, then maybe we could build a containment that envelops this whole area, so we have an airlock, and then we can build a zip wall across the opening here so that we have our primary containment. If that's not going to work for the client, then there's other ways we can go about it, or we could establish the fact that we don't in fact need to put an airlock in this room for whatever reason. One of those reasons might be the fact that in both corners of this room we have full opening windows which could be used if necessary as a way of ingressing and egressing out of the work site. This is always my preference, to be able to exit the work site directly to the outdoors rather than walking anything through the indoors. Even though you've got that contained off, it's still a preference, if you can, to isolate that completely from the house and then just to work directly in and out through an opening window or door preferably. And here we have our third scenario, a big open living space with a fairly isolated problem we're going to say is on that wall there. So we have several options with a space like this. One of the considerations here would be, we don't want to impact too much space or too much of the home if we can help it. Now we're going to say, for the sake of this scenario, that the mould problem in this room is about the size of that painting on the wall there. So our options are, we could isolate off this whole room, which would mean moving all this furniture out. Another option is that we could put an isolation just over the affected part of the wall. I don't usually like doing that, because sometimes you find that when you start cutting it out that the problem is in fact bigger than what you've allowed for, and then you start running into problems downstream from that. So my preference for a scenario like this would be to build a containment wall across here and then across that corner. It means that we won't be moving too much furniture out of the way, and we can keep the impact as low as possible for the homeowner, as well as effectively contain the area that we need to contain. Let's first start off with the equipment. The equipment that you're going to need to start with is a ladder, so that you can get to the ceiling height safely, a negative pressure unit or an air scrubber, and a containment kit. We use the zip wall system, which is a very easy system to use, and we'll show you how to build a containment wall very shortly with it. So in this kit, we have the zip wall system itself, which consists of the feet, the non-slip pads, and the poles. This kit came with 4 poles. You'd need at least 4 really. You can get bigger kits with 6 or 8 poles in them. So you need at least 4 poles really to do an effective containment. In addition to the kit that is provided, I also have a tape, a good sharp knife with spare blades, a few pieces of timber about 1 metre or 1.2 long. These can be very useful for putting a base along the bottom of a doorway or across the top of your opening so that it doesn't sag. Cloth tape and 2 different types of masking tape that generally do not lift paint off the walls, so that you can safely stick your containment wall to the plasterboard. You can buy plastic in rolls, or I prefer to purchase them as drop sheets. I get 2 different sizes, 2.6 by 3.6, or the extra large ones, which are 3.6 by 5.4. I find these very useful because they're nice and light. You're not having to try and handle a whole roll of plastic while you're building your containment, and you know what size you've got already. So now we've got our equipment, we have our ladder, we have our air scrubber, and we have our containment kit. Let's go build a containment. So the material we're going to use for our containment is heavy duty plastic drop sheets. You can buy these in rolls or buy plastic in rolls. I prefer the drop sheets just because they're a little bit easier to manage. They're nice and light, and they come in 2 different sizes, 2.6 by 3.6, or the large one is 3.6 by 5.4. So we just need to measure our space first and see what size plastic we're going to need. So we're going to want to build our containment out to at least this point. That measures 3.7. So obviously the sheet that's only 3.6 is going to be too narrow. So we'll use the larger sheet for that. So we're going to need the extra large sheet, 3.6 by 5.4. Obviously if you're using a roll, you can cut off to exactly what you want, but I recommend cutting over length by at least 1 metre so you've got plenty to play with. So once we've unrolled our sheet, we want to find one of the top corner, or the top corner. Using the zip wall method, unclip the foot, place the plastic over it, flush with the edge, and about 100 millimeters away from the very end. Put the foot back on top and clip it in. That way you've got a little bit of a tail hanging over the side. Extend your top pole first, and then your bottom pole, and push up against the ceiling until the spring is about halfway compressed. Then approximately halfway along, or no more than 2 meters away from the corner, we'll put in our next pole. Again, you want to make sure that the edge is flush with the foot, and that way you know that your top is going to maintain a nice straight line. Again, extend your pole till the spring at the top is about halfway compressed. Our next critical point is where to put this corner. Of course, it doesn't have to be exactly square, but the nicer and straighter that the containment looks, the better it is for everybody. You'll remember that we left about half of the spring exposed at the top. That's so that we can have enough room to lift that foot up to slide the plastic underneath. Remember to place the non-slip pads underneath each pole so the bottom doesn't slide in. The next part of the process is to tape up. I like to use a very non-stick masking tape so that we're not going to pull any paint or do any damage to the surfaces that we don't have to do. I find it helpful to fold the excess inside the containment and just put a little bit of tape to hold it in a couple of areas, and then you can seal tape all the way down. So there's three different methods for creating an opening into your containment. One is the zip wall stick-on zip. You literally just stick them on, open up the zip, put a knife through and cut through the plastic, and then you've got your door opening. These ones are better if you want a proper door-sized opening because they have a curved zip on them. They just take a little bit longer to install, but I'll show you how to do that now. Once the door has been positioned and secured into place, you can then start seal taping it up around the edges. For this, I like to use cloth tape because it sticks a little bit better to the material that the door is made out of. So now we've got our containment set up. What we want to do next is straighten everything up, tape it all down, seal up all the edges and make sure it's going to last the job. So we have some excess on the floor here, and if it was left like that, it would create quite a bad slip hazard. So there's two things we can do with this. One is to either tape it to the floor, which is advantageous in that it helps to maintain the seal of the containment. However, even with it taped down, bear in mind that there still could be a bit of a slip hazard or bunching up and a trip hazard. So if you are going to tape it down, make sure it's nice and flat and tape it down securely to the floor. However, if you did a risk analysis of what you're actually doing here on the wall, you may opt instead to roll that back, keep it along the edge, tape it out of the way so that you don't have any chance of slipping or tripping over the plastic. Bear in mind, if you go for that option, of course, that you might have some additional cleaning to do on the floor once you've completed your removal. One of the problems that you might encounter with the opening into your containment is a sagging of the top between the two poles that surround your containment opening. One way to fix that is to support between those two posts with another piece of wood. So now our containment is built and it's sealed up, but you'll notice that even though that window is closed, it's still allowing enough air movement in to start moving our containment wall. This means that if we had mould aerosolized on the other side of that containment wall, there is a chance that that wind pressure would push some of that fungal particulate outside the wall and start contaminating this area. So how do we prevent that? Well, we have to apply negative air pressure. So this is our negative pressure unit, obviously with the HEPA filtration side of it. There are many different styles of units. This is the one that I like because it's very nice and very easy to sit into the containment. This one is also adjustable, so even though it's very, very big for this size containment, we can easily reduce its capacity so it's the right size. What we do want to do is wherever our fresh air is coming in from to replace the air that's been evacuated, we want to make sure that we're at the other end or diagonal corner of that for our negative pressure unit. In this case, I think we'll pull fresh air in from the window because we can adjust that as we need to quite easily. So we'll put our negative pressure unit up here near the door. Usually though, you're trying to avoid the doorway and get either halfway down or the opposite end from the door. But in this case, because we're pulling our fresh makeup air from this corner, we want to pull it out from the opposite end. So here we are back to our first scenario with the bedroom, which we want the whole bedroom to be contained because the work is going to involve more than one surface of that room. So our containment will be by way of an airlock between the door here and our main ingress-egress to outdoors, which is the front door here. So of course, one of our considerations is where we're going to put our negative pressure unit and how are we going to exhaust that to the outdoors, outside of our containment. Obviously we can't do it here because it's within the cleans zone, and we really need to continue our draft through this way. So the only way to exhaust it would be out of one of these three openings. So in this case, I would like to use this opening as our exhaust for our negative pressure unit. I think this would be the easiest because we can simply open up the bottom of that window. We can place a piece of ducting on the negative pressure unit to outdoors and then seal around that opening with plastic. Alternatively, we could set up the negative pressure unit outside and press the face of it up against the window and have a seal that way. The advantages of having the unit on the outside of the work zone is that the outside of the unit doesn't get contaminated, so we don't have to worry about cleaning down the outside as far as contamination goes. Disadvantages, of course, are a lack of security. So if we had to leave that running overnight, then that would obviously pose a problem. Whereas if it's inside the containment in this case, whilst it might be in our way, and whilst we might have to clean it down, at least we can maintain security overnight if we needed to. So we have a sheet of plastic which is 2.4 wide by 3.6 high. We want to use the 3.6 in this orientation because it's a 2.7 stud, so we need more than 2.4 that way. So what we can do here is we could actually run our plastic from this corner here through to this mullion on the door, and that could be our airlock. It's quite small and it would be nice to be bigger, but one of the advantages to running our containment through this line here is it means that our client, when they're using upstairs, they can easily come around and get to the stairway without being blocked off by our containment. So for the purpose of this containment, we're going to run it through from this line here through to that corner there. So for containment of this size, we're going to need 3 poles. So I've got our 3 poles ready. We have our plastic, which is 2.6 by 3.6. We want to roll that out and unfold it so that we can locate the corners. Once we have our first corner located, we'll clip it in. I always like to make sure that the foot is parallel with the edge of our plastic, and give yourself about 100 to 150 mil overhang at the end. You'll see why in a minute. I already know that the sheet of plastic is the right length to go across here because I've measured it earlier. So I can set the other end the same way, about 100 to 150 millimeters in, with the edge of the plastic parallel with the edge of the foot. Now you want to make sure that the poles end up on the inside of your containment. That's so that when the negative pressure comes on it, the plastic actually pushes up against the poles. Extend the poles so that the spring is just compressed over a little over halfway. The 2 poles would probably be enough to support this. However, we have extras. I would like to put at least 1 more in, which you could clip in properly like the first 2. Alternatively, you could just use it simply to press against the ceiling without clipping it in, and that will give it just a little bit of extra stability. So our plastic is now up, it's supported. in all four corners. It's stretched relatively tight, but not too tight. Now we just need to seal up all of the edges with tape. So we now have our perimeter tape around the outside of our containment. The excess plastic along the bottom we've just tucked out of the way. Sometimes we'd like to put plastic over the floor itself as well, which would save us doing the cleanup there. However, when you're deciding whether or not to put plastic down, bear in mind that it does become a bit of a slip and trip hazard. So I like to avoid that. I'd rather tuck it up out of the way. It just means that I have to clean down this floor as well. But that being said, I'd still have to clean out the entire containment anyway. So to me, that's not too big a deal. So the purpose of our airlock is to maintain that negative pressure as we're entering into the workspace. This works because when we open our first door, our negative pressure is still maintained by our second door. Then we close our first door and enter in through our second door, and the negative pressure is maintained there all the way through. So this is the space that we can use to don and off our PPE and clean down any bags or rubbish that we're taking out. We'd have a vacuum cleaner set up in here so that we can clean ourselves down, clean down all our bags and our tools and equipment before we were to take them outside. A couple of things to bear in mind is that discretion is often a big part of how we handle the customer's expectations. No one really wants to see men dressed up in heavy PPE coming and going from their house. So the good thing with this is that discreetly off the street, we can be getting changed in and out of our normal clothes and into our PPE. In the scenario that we talked about earlier with the full lounge room, we would build something very similar, but just a taped up wall of plastic that completely seals off this part of the house. All our entry and exit into the work site can be via this window. We would anticipate that a job in a room like this would be quite small. You'd probably only be in here for 2, 3, 4 hours maybe at the most. So entering and exiting through a space like that would be quite okay for a job of that nature. What it does mean is that with that wall up over the opening, it means that there's no chance of any of the contaminants escaping in through the rest of the house. All our entry and exit is done directly to the outdoors. So the way we would build this wall would be in very much the same manner as we built our scenario number 1. We could use the poles running from the floor to the lintel here, or alternatively, we could just tape plastic directly to the plasterboard and the perimeter around the outside of that opening.